Good morning, chemistry. I am out today, as you already knew, with a personal day. So we have a couple of things we need to go through, because as you can see, we have a test coming up on Friday. Actually, that's not a test, that's a quiz. So don't stress too much. But we're going to start with a couple minutes of bell work. So your bell work question today is, when curtains fade in the sun, which factor, and those are of the four factors that affect reaction rate, temperature, concentration, all of those, is affecting the reaction rate? And then explain your reasoning. So you've got a little less than 3 minutes to answer this question, and then we'll come back. While you're working on it, we'll just listen to some holiday favorites.
Dashing through the snow in a one-horse open sleigh, o'er the fields we go, laughing all the way. The bells on bobtail ring, they make our spirits bright. What fun it is to ride and sing a sleighing song tonight. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. A day or two ago, I thought I'd take a ride, and soon Miss Fanny Bright was seated by my side. The horse was lean and lank, misfortune seemed his lot. He got into a drifted bank, and we got upside. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Now the ground is white, so go it while you're young. Take the girls tonight and sing a sleighing song. Just get a bobtail nag, 240 for his speed. Then hitch him to an open sleigh and crack, you'll take the lead. Oh, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh.
So let's go over this. So let's say you have a set of red curtains, and you hang those red curtains on the side of the house where the sun is always shining to keep it out. So, I don't know, a couple months later, you decide to move those curtains or wash those curtains or, do whatever it is you want to do with those curtains. And you find that rather than being bright red, now they're kind of a light red, almost pinkish color. So, if we look at that, what is affecting that? What does the sun actually change about that reaction? Okay, so I'm hoping that most of you decided that the sun increases the temperature and affects heat. So an increase of temperature has sped up the process of the fading. Okay, if you had hung those same curtains in a window not facing the sun, they would have lasted a lot longer, or at least they would have stayed red a lot longer. So increase in temperature, that's what does it. Alright, so we're actually going to move our schedule around a little just for the ease of your sub. And we're going to take the video and we'll move it here after the notes. Alright, so please pull out your notebooks or pull out your printed notes because we're going to go through those right now. Alright guys, so here is your first page of notes. So please write this down. You have about 2 minutes. Alright guys, so today we're going to look at what's called percent yield. Now, we know that the word yield means basically how much is formed. So we're looking at what percent of what should have been formed actually is. So, the way to find percent yield is to do your actual divided by your theoretical and then multiply it by 100. So a pretty basic math problem. The big thing that people usually mess up is the difference between their actual and their theoretical. So, when we talk about actual, we're talking about what you measured out in the lab. So, how much you actually got. The amount that after you do your experiment, you put it on the balance and it tells you this is the mass. The theoretical is the amount you expected to get. So this is where everybody's favorite stoichiometry would come in. Okay, so you do stoichiometry to figure out you should have gotten 76.4 grams. But then when you measured it out to get your actual, you saw you only got 74.2 grams. Okay, so we do our actual divided by our theoretical. And then multiply by 100, of course, to make it a percent. Okay, and if there are any questions on any of this, you guys can message me on Edmodo. Don't forget that that is available to you. So let's look at an example. So this is a simple example. Why don't you go ahead and write this down and then we'll go over what it means. Alright, so now let's go over this. So this is a simple example. We can look at a more complicated one together when I'm back tomorrow. So if you form 27.8 grams of water in a reaction, but you expected to form 32.4 grams, what is the percent yield? So looking at that problem, because we do form, so this is the amount we measured out in the lab, the amount we actually formed, this is our actual. Okay, if we did out a stoichiometry problem and we saw that we expected to form 32.4 grams, this is our theoretical. So all we have to do is plug those in. So we have 27.8 divided by 32.4, right, grams of H2O cross out, and then multiply it by 100. So we get 0.8580246 times 100. So let's round that. Right, we move the decimal over 2 places, and we get 85.8% yield. So what this means is that we produced 85.8% of what was expected. So this is something that's done a lot in industry. You want to get the highest percent yield possible. Right, if you take a look at your gas mileage on your vehicle, right, the bigger your vehicle is, the worse gas mileage you're getting. So the lower your actual yield is. Okay, what people try and do, and what scientists try and figure out in terms of cars anyway, is how to get closer and closer and closer to a 100% yield. Okay, now this is nearly impossible just because things are lost. So something turns into a gas, or you end up through the process forming something that you don't want, so you get rid of it, or it's released as heat, so you lose part of that energy. Okay, a 100% yield is very difficult. Okay, but if you have yields up in the 80s and 90s, like this example did, that's pretty good. It's when you start getting down and having like a 60% yield or a 30% yield that you really have some problems. Alright, last page you have to write down. So we won't go over this one today because it is a bit more complicated and it takes going through a stoichiometry problem in order to solve it. So what I would like you to do is write it down so that we can go over it all together tomorrow. Now feel free to give it a try if you remember how to do stoichiometry to figure out that theoretical yield. Okay, so take a couple of minutes and write this down, please. And now let me introduce you to the noisemakers in the background. These are my two puppy dogs. There's Hitch, he's the big one, and Leela, she's the small one. They like to play with squeaky toys and each other and make lots of noise. So this is Hitch. He's a very good boy, very high energy, loves his little sister. And this is Leela, who is adorable and sweet, and again, very high energy. So I hope that everything has been clear in this explanation. If not, again, feel free to send me a message on Edmodo or email me at mrs horn.fhs@gmail.com. And I will be back tomorrow. We can go over some of the problems. What you're going to do now is you'll be watching a short video that also talks about percent yield. When that is done, you're expected to work on your review guide. Okay, so we do have, again, a quiz on Friday. So we can go over anything we need to go over. Okay, go back over a little bit of stoichiometry because you will have to use it at least once in this quiz. Okay, and we will probably look at doing an activity or a lab over the next day or so. So please be ready for that. So again, the rest of your time should be spent working on your review guide. Have a wonderful rest of your day, and I will see you tomorrow when I get back.